Okay, for another worksheet that I have for you to do this week, it deals with parallel lines that are going to be, in this case, they say divided by transversals. I like to say cut by a transversal. So parallel lines, if just something to remember, if you ever see like arrows on your segments that may be present, that's going to say that those lines are going to be parallel to each other. In the examples on your worksheet, they do not mark them that way, but maybe on the actual ACT test, maybe in John Baylor, they talk about those arrow segments, and that when you see those arrows, that means that they are parallel to each other. So we have these two parallel lines, and a transversal just means that you can have a line that crosses through those transversals, or through those parallel lines. As you look at it, you have 8 angles that are created. If you go back to some note cards, you're probably going to find out that those pairs of angles have different names. We've talked about corresponding angles are equal, vertical angles are equal, alternate interior angles are equal, alternate exterior angles are equal. But you don't have to remember all of those names because they probably will not make reference to those specific, that specific terminology. So as you look at it, if I were to get a problem that dealt with parallel lines, what I would do is just go through and start to mark the equal angles. So 1 and 5, they are congruent to each other because those are corresponding angles. 1 and 4 are vertical angles. 4 and 5 are alternate interior angles. But you don't need to know that. Just remember that opposite angles, which are called vertical angles, are equal. So 1 is equal to 4, and then you just slide that down and keep that pattern going. So as you look at it, then you will also know that the other two, the other angles that are left, are also going to be equal to each other. So the ones with the dots, 2 and 3, 6 and 7, those are all equal to each other. So there's only really 2 measures that you have, and between the blue arced angles and the purple dot angles, the 2 together are going to be supplementary. Remember, supplementary equals 180 degrees. So between the tick marked angles and the dots plus an angle that is a dot, those 2 angles have a sum of 180 degrees. And if you remember that, then you should do pretty well with trying to find problems that deal with that. Now, the first example that I have for you may happen to be problem number 2 in the worksheet, but it says in parallelogram ABCD. So in that parallelogram, information that you know is that these 2 sides are going to be equal to each other. AD is going to be parallel to BC. I said equal, they will be, but they are parallel to each other. And then to designate a different set of parallel lines, we're going to use 2 arrow tips right there. So we know that it's a parallelogram. What is the measure of angle DAC? So maybe the first thing to do is to go ahead and figure out what they are asking for. They are asking for angle DAC, so I'm going to mark this angle right here, X. This is what they are looking for. So to solve this particular problem, since it's a parallelogram, all you have to do is look at, you have these 2 parallel lines, and you're going to form a Z. Now remember, inside your Z are the angles that are going to be equal to each other. What forms the angles in your Z are going to be congruent or equal to each other. So angle X in this case, or angle DAC, would have a value of 55 degrees. Just always make your Z and know that the angles that create that Z are going to be equal to each other. Now, something else. Yeah, you could go through, I don't know, there's a lot of things you could do, but that's the easy, quick way to get to an answer because this is, the ACT is a timed test. So if I look at the second example that I have posted for you, which does happen to be example number 4, sometimes people do not like geometry problems. They don't want to spend the time to try to figure this information out. So it tells us that in the figure, J is parallel to K. So I know that these 2 lines are parallel to each other, and then they tell you that MN are parallel to each other. So we have a parallelogram that's actually created there in the middle, and there's different ways we can go about trying to figure out what is the measure of angle X. So I have it marked in the diagram, and there's a lot of different ways that you could go about trying to find it. I don't know how you are actually going to look at it in terms of a z. If I look at it in terms of a z, you have these two parallel lines right here, and you're going to cut it by this transversal. So alternate interior angles are going to be equal, or there's your angles that create your z, and they are going to be equal to each other. So as I look at it, if this is 110 degrees, this angle right here, here's what you could do. You have these parallel lines cut by transversal. I know that this set of angles, those sets of angles right there, are going to be equal to each other. So let's just look at these two parallel lines cut by transversal K. Right here is marked 110 degrees. So I also know that this angle right up here is 110 degrees. Now what they have done is they have split that. I'm going to take this transversal right here, transversal T, and I'm going to sketch that into my graph. And in transversal T, I have this parallel line, which is K, and I put in the next parallel line, which is J, cut by this transversal. So if this is 30 degrees and that whole angle is 110 degrees, that means that I am going to have 80 degrees for this angle right here. So that angle is 80 degrees, and X is an equivalent angle to that. So X is also 80 degrees. So I know, once again, this is 110 degrees because they land in corresponding positions. So 110 minus 30 gives you 80, and then you have alternate interior angles here, or these angles are going to be congruent to each other because they form your Z. So that means that X has a value of 80. Okay, so that is example number 4, but 5 follows the same concept dealing with that. So I will let you go ahead and answer number 5, dealing with that same concept for the most part. Your Z might change just a little bit, but just know what angles are congruent. Okay, another way they may ask you this question is they're going to give you a figure such as the following. They're going to say B happens to be on line segment DE, and then they're going to say DE is parallel to AC. Then they're going to ask you which congruency statement must hold, or must hold means which congruency statement is true. So if you have parallel lines, once again, as you look at it, here are your parallel lines, and you talk about this transversal. If I talk about that transversal, I want to look for my Z, and my Z occurs right here. So the angles in your Z are saying that angle 1 is congruent to angle 4. Now there is another way you could look at it. You could sketch your parallel lines and deal with this transversal, and in that case your Z forms this angle 3 and this unknown angle right there. But those are going to be congruent angles, so I know that 1 is the same thing as 4, so there's your answer. Just knowing that you have parallel lines cut by a transversal, which angles will be equal to each other. Okay, so something else that the ACT likes to do is just trip you up on making sure that you know how, or you are being careful of reading your particular questions. So they're going to give you this particular problem, and it says in the figure given, lines J and K are parallel, which I have marked, and lines M and N are parallel. Which congruencies do not hold? So which one does not hold? So as you read through your question, I would somehow make note that it says does not hold. Now the first thing that I would do is probably just go ahead and cover this up so you just see parallel lines cut by one transversal, and just go ahead and mark what congruent angles there would be. So if it doesn't have the tick mark, then it's supplementary to the ones with the tick mark, but all of those without the tick mark are also equal to each other. Now the same thing is going to happen if you move downwards. So if I were to cover this up right here, now I have parallel lines cut by transversal M. So you could think of it, if you wanted to, as turning your paper And if you were to turn your paper, then you're in the same orientation that we were before. And you can see that these two angles are going to be equal to angle 5. Now along the same concept, I could cover this up and go ahead and mark what angles are equal. Or what you could do is get rid of this top line and then you're marking corresponding angles again. So every single one, this whole diagram only has 2 angle measures that are supplementary to each other. The ones marked in red are going to be supplementary to the ones that are not marked. But only 2 angle measures are formed. So this one says which one does not hold, which means is not true. These may not be in the same order that problem number 8 is on your worksheet, so don't just go by the order when you answer it. Make sure you answer the correct one, because I switched the orders up. So as you go through angle 1, does angle 1 equal angle 4? Oh, no, 1 does not equal 4. So I'm just going to mark this as no. Check the others. Is 1 congruent to 5? Yes, it is. Is 2, which is unmarked, congruent to 6, which is unmarked? Yes. So that is yes, that is yes. Are 2 and 4 the same? Yes, they're both non-tick marked angles. So that means that they are equal. And does 3 equal 6? Well, 3 and 6 are both unmarked angles, so yes, that is true. So your answer is 1 is congruent to 4. Just be careful of how they ask those particular questions. Are they saying that they are the same, or are they saying which one is not true? Okay, just real quickly on this last example here, what I want to point out to you is they might give you congruency statements. So with congruency statements, for an example, they might say that angle 1 plus angle 2 is congruent to angle 5. Well, if you look at your parallel lines right here, and if you cut it by this transversal, you see that that is not true. Angle 1 is equal to angle 5. Maybe one of the statements they are going to give you says that angle 1 plus angle 2 is congruent to angle 4. Well, if I look at these parallel lines right here, and if I cut it by this particular transversal, which I have marked, I realize that 3 and this unmarked angle, so I'm looking at just these 2 parallel lines here cut by this transversal, and I'm going to mark angles that are equal to each other. So if I mark those angles, then that tells me that these other angles have to be equal to each other, and this is angle 4, but this angle over here happens to be 1 plus 2. So 1 plus 2 would happen to be equal to or congruent to the measure of angle 4. Okay, so that's all I have with parallel lines that are divided by a transversal. I like to say cut by a transversal, but I hope this helps you with your worksheet. Your worksheet will be 1 through 10.